Hello folks, today we're going to talk about how to solve problems with average velocity in connection with displacement. So let's get to something a little different. There's a pen. So when we talk about average velocity and displacement, we're looking at how these two are related and how we can solve velocity, displacement, or time. So the equation to use is this simple equation. We're going to be using a little bit of both, and we get to manipulate these. So this is what I expect you to do is if you have an equation like this, I want you to know how to move it around so you get the isolate the variable to how you want to do. This is just algebra 2, folks. This is everybody should have this. So our average velocity is equal to delta, which means change in. So delta x is one variable and delta t is the other. This is time. So final minus initial, final minus initial. So every time we see change, this means final minus initial. Okay? So now we're looking at average velocity, change in distance or displacement over the change in time. So the question is, we have this fish. The fastest one is called the sailfish. And it can swim 1.2 times 10 to the second kilometers per hour. Suppose you have a friend that lives 16 kilometers away. We want to know how long it would take for you to send a message to your friend. All right, so we've got to look at units, and I'll come back to this. Units for this must be in meters. T must be in seconds. All right, time is in seconds, displacement is in meters, and all your answers should be meters per second. And that's velocity, units, meters per second. So coming back here, we may have to do something about the change these units. Distance over time, that's going to equal velocity. So we have a velocity. And this is a distance. And we're looking for time. So velocity, we have distance, we're looking for time. And that's going to be our velocity is equal to change in distance over the change in time. Now let's see how we're going to get these variables. So we've got xf, final distance, initial distance, final time, and initial time. But we have velocity. So our velocity is equal to, 1.2 times 10 to the second kilometers per hour. We need to convert this. Just hold on a second. Initial time. We're looking for the change in time. How long will it take? So we're looking for the change in time. So if we start the fish off at me, or you, that's time 0. So we're looking for the change in time. So come back here, we're looking for the change in time. This is what we don't know. Do we have distance? Going back up here, a friend lives 16 kilometers away from me. I'm on the shore. Shore is going to be x is equal to 0, and the island is 16 kilometers away. So this is 0, this is 16 kilometers. We need to convert this as well. Now, part of this problem sets that you're going to have to do, you need to figure out how to do the conversions. This is going to be required. I am not going to tell you the conversion factors. You need to look these up. So 1,000 meters is equal to 1 kilometer. If I have 16 kilometers, I'm going to have 16,000 meters. That's going to be x sub f. If you want to do it in equation style, 16 km. You've done this before in chemistry. 1 kilometer is equal to 1,000 meters. And we're going to get 16,000 meters. Now my velocity. Velocity is equal to 1.2 times 10 to the second kilometers per hour. Now, excuse me, I meant to put a plus. So what I'm going to do is I'm going to take 1 kilometer, multiply that by 1,000. Then I'm going to take 1 hour divided by 60 minutes. And then 1 minute is equal to 60 seconds. So for every 1 hour, you got 60 minutes. For 1 minute, you got, let's go MIN, you got 60 seconds. So if we do this, if we do the math, 1.2 raised to the second times 1,000, and then divide by 60 times 60, we're going to end up with a value of 33.33 meters per second. That's how fast this fish is going to swim. And this is going to be the average velocity. So, we've got velocity is equal to distance over time. Now, how you want to solve this is up to you. I am going to change the equation with the variables first before I do anything else. That's just how I like to solve it. Now, some students like to put in the numbers first and then figure out what the variable is. That is fine. Either way, how you solve this, it doesn't matter to me as long as you get the right answer. Now, I'm going to take t and move it over to the left by multiplying both sides by t. So v times t is equal to x. Remember, I'm multiplying both sides by t and distributing through. And then I'm going to divide by v. So time is equal to distance divided by velocity. So t is equal to my distance, and that was over here, 16,000 meters. And I'm going to divide that by my velocity, which is 33.33 meters per second. Now, if I divide 16,000 divided by 33.33, I'm going to get a time of 480 seconds. Now, how do I know that by time? Let's look at the unit analysis. I got meters times 1 divided by meters per second. That's the same thing as going meters times seconds over meters. Meters cancel, and that gives me seconds, and this will give me seconds, and that's what we have here. So this is going to be the right answer. So the answer is going to be 480 seconds. And this is what I want to see, folks. I want to see the variables. I want to see how you convert. So I want to see this, list of all the variables, how to convert, converting over to this, and give me the answer.